Chapter 8 covers systems of equations and inequalities. We will only be looking at section 8.1 on systems of linear equations and using the techniques of substitution and elimination. A system of equations is a collection of two or more equations, each containing one or more variables. A solution of a system of equation consists of all values for the variables that are solutions of each equation in the system. To solve a system of equations means to find all the solutions of the system. So it can be more than two equations. However, for our purposes, we're just going to consider the minimum two equations. So if you have two lines that you graph in the same coordinate plane, there are three possible outcomes. So let's look at those. The first possible outcome is you graph one line, then you graph the other, and it turns out that they intersect at some point, some coordinate point there. So the lines intersect is the first possibility. In this case, this system of equations, two or more equations, and we're looking at linear, so they're lines, we have one solution. And that solution is the point I've labeled there, xy. This is considered to be a consistent system. Okay, well, another thing that could happen when you graph two lines in the coordinate plane you find that they're parallel. So how many solutions does this system have? Well, it has no solution, because remember, their solutions are points that satisfy all the equations in the system. So it has to be a point on every equation in the system, and there are no points that are on both of those. This is an inconsistent system. Finally, if you're given two equations and you graph them, and it turns out that they are the same line, or lines are the same, so how many points do they share? Infinite solutions, because every point on the first line is shared with every point on the second. This is also a consistent system. Okay, so just visually, this is what we're talking about. We're not going to be graphing, though, actually. We're going to find out how to do this algebraically to find out what is that one point they both share, or is this the case where these two lines are parallel, just given the equations, or is this the case that they're the same line? All right, so there are three ways to solve the system of linear equations, and of course the first one is to graph, and that works just fine if your intersection is at integers, but if you intersect at some very difficult to read off of a graph fractions, that's not the best way. So that's not the way we're going to do it. We're going to be using algebra. And there are two methods there that were mentioned up here above: substitution and elimination. It doesn't matter to me which method you use. Sometimes the homework might tell you to use a particular method, but that is not a concern of mine. I just think you need to be able to solve them either way. The truth is, if you know both methods, then you've got a better toolbox for solving these problems, because some systems they're just more efficiently solved by substitution, and some systems are more efficiently solved by elimination. So It's not wrong to use one or the other. It just may take you more steps than it would take someone who chose the other method. That's all. Okay. So in the first example, we just want to be sure we understand what we mean by solutions of the system. So they're going to give us a first pair of points, or 2 points. We're going to look at the first one, and here's our system. And first question is this point 4, 4 a solution to that system? So it has to satisfy both. So let's check it out. For the first one, we'd have what? 4 plus 4 equals 8, or 8 equals 8. So far so good. It is a solution to this one. And 3 times 4 minus 4 equals 4. 12 minus 4 equals 4. 8 equals 4. That's not true. So no, 4, 4 is not a solution to the system because it only worked in one of the equations. All right, let's try 3, 5. Of course, 3 plus 5 equals 8. It does work again in that first equation, but let's try the other one. 3 times 3 minus 5 equals 4. 9 minus 5 equals 4. 4 equals 4. It also works here, so our answer would be yes. So that's just to help us get that understanding of what we mean by a solution to the system. It has to satisfy both.